Well, um, what I want to do now is catch snippets of voice. And for now, I want to output those snippets of voice and I'll maybe make it a visualization using those bouncing balls. So whenever I say something past a certain threshold, we stick that into one of those bouncing ball objects along with the audio reference. And it gets played back when it hits a wall. How's that? I think that's going to be a little too noisy, but we can try doing the first half of that. So get calculate. No, first we have to have our loop. Look at the new buffers. So know that this is not happening in the audio callback, in the input callback, but in a different thread, in the game engine main thread. I don't think it's a main thread, but it's a separate thread, non-GUI thread. So we want to look at the new buffers, and we can do that by, how do we differentiate a new buffer from old one? Well, I don't think there's a good way to do that yet, because we don't have flags, and we will need flags. So I think what I want is input manager .h. There we go. And so here I have a list of input buffers. This is trickier than I thought. There can be gaps in this vector. This has a bunch, will have a bunch of vectors, audio buffers, but if they're numbered from 1 to 100, say, the middle 25 to 30 might not be there. So we can't just do something like a straight up list or number system. Instead, I would like to use well, we want to keep track of the last thing that was analyzed. Okay. You know, the simplest option, it's not the most efficient one, but I'm just going to do that for now. Analyzing. That would be a bit of a hack, but I'm going to do this. We already have the analyzing flag in there, which was also a hack. But this is what we can do. We'll say 2, and we'll note that ref count, analyzing count of 2, 1 for start, analyze, 1 for finished. Yeah, actually, I mean, a lot of our names are a lot of the names aren't so honest, right? Analyzing period or whatever. Analysis seconds. Yeah. I have to make a note before I forget that when we throw them out here, and we can delete this printf statement. To do. Oh, it looks like it's %LLU for 64-bit unsigned integers. That would make sense. To do. It's a bit of an ADHD period. of my day. I'm sorry. To do. God damn it. Recycle these buffers instead of deleting them. Turns out that, well, allocation and deallocation is not such a big thing with these small, this is maybe 1K of data, 1 kilobyte. It's not such a big impact, but at least good to note. We could get it, once we allocate a certain amount, we shouldn't need to delete and reallocate all the time. Okay. So look at the new buffers, and we can do that. This is how we can do it now. You see, once we finish the analysis period, we decrement analyzing. And we also decrement ooh, this kind of sucks. And we also decrement okay, here. This is how we'll do it. This is getting a little ugly. I could do this in one loop maybe, but I want to separate them for now. Yeah. For I equals 0, I less than... We have to go over the whole thing. Well, it's not really an issue if we start at the end, right? New buffers get added to the end. Yeah. Old buffers are added at the beginning. Correct. So, looks like we can just copy and paste this. So do we want to start from the old buffers? Yeah, sure, why not for now. It'd be more efficient to go the other way around, but I think that is a premature optimization at this point. Actually, it's not really premature optimization because there's going to be hundreds of these buffers. And we only want to look at so many. So, this is what we do. We do a first pass, like so. So this will be a size t for an index, and first unanalyzed index. Nobody minds if you do a complete thingamabob. So a full name. If m input buffers I, and what do we want? What do we want? We want analyzing. If that equals 2, yeah, then we will say that analyzing index equals I. This is totally stupid. There's absolutely no difference in this code. Yeah, I could do. I think I intended to do binary search, and just downgraded it for simplicity's sake to a for loop, and ended up being the complete same thing. Oh, the root of all evil. Premature optimization, baby. Okay, so I'm here and I'm in an unanalyzed buffer now, and this is the start of many to come, or at least one or two. What I want to do is I'm going to use a basic threshold. So it's very hard to figure out the threshold ad hoc, because I don't know how responsive this microphone is, and they may be different from one to another. But for now, right now, I don't give a, I guess I don't give a damn. I'm just going to pick a large number, K. What do we want to call it? Onset threshold. And it's going to be power. I don't know if that's what it's called, but root mean squared. It's not a root mean squared, it's a mean squared. What do you call that? Squared. Let's just say that for now. And we'll call this, so I'm looking at the debugging output from this guy. What is it? I don't know, so it tends to stay around, how many digits is that? 1, 2, 3, 4, 5. Why don't I just copy and paste one of these? Yeah, this looks like the biggest, one of the biggest ones. So I'm just going to paste that there. I'm going to add one significant digit to that and just call that good for now. I think that should cut out most noise. Okay. And this time I did not add a semicolon, so I'm improving leaps and bounds every time we get together and do a YouTube quasi-extreme programming session. Except that I'm trying to set the value of a constant now. God damn it. So I'm going to steal from our callback, which is in filter audio IO.mm. We already calculate the squared power. God damn it, what do you call that? It's been a while since I've talked DSP. When you do it all in your head, I mean, you don't really say squared without, but you say root mean square. Where did it go? I think it's right here. Yep. Yes. So this is a stereo channel. Probably shouldn't be a stereo channel, but for now, really who cares? Alright. I'm doing the very scary thing of changing